Hello, everyone. I think it's time to start the new session about some industrial experiment on the use of ammonia as fuel. So first, I'm very happy to introduce Youngmin from Korean Institute of Energy Research. I met him a long time ago, near 10 years ago. And because I have seen for the first time a car with some ammonia as fuel. So Youngmin received his PhD in mechanical engineering at KAUST. He's a principal researcher at KIER, and his research field include combustion in internal combustion engine on vehicles, and especially with newer renewable fuels to draw both better energy efficiency and emissions. So please, Youngmin, can you? Yes, it's okay.
Can you see my slides?
Yes, it's perfect.
Thank you. Thank you for nice introduction of myself or of me. Good morning and good afternoon and good evening. I'm Youngmin from Korea Institute of Energy Research. Today, my title is Ammonia fuel application in a conventional vehicle. I'm very happy to be here and to give you some previous work and current work. Yeah, very honorable. Thank you for the invitation. This is the content. I will briefly touch the background of the research and then move to the ammonia fuel combustions in several cases. And I would like to start with the nationwide greenhouse gas emissions first. On the right-hand side, we have nationwide greenhouse gas emissions in my country, and most of them are from the industry, from the energy industry and manufacturing and construction as well, and some industrial processes as well. And the gray piece is for the transportation sector, and it accounts for about the 14% of the total emissions. From early 90s up to the 2010, we have a drastic increase of the emissions, and it doubled, more than doubled in these 2 decades. That means 10% increase every year. But after 2010, we have a slightly increase, almost 1%. And now the government try to reduce, a drastic reduce by 2030. In transportation sector, we have to reduce more than 30% of the greenhouse gas emissions. That's why we are focused on the new fuel, ammonia, in the transportation sector as well. And this is our previous research and current research. We are one of the governmental research institute of the country. We have the Fuel Economy Certification Authority. One of the authorities, we are doing the public service, and we focus on mainly on the alternative fuels such as LPG, CNG, and biodiesel, DME, hydrogen, and ammonia. And most of the talk about today is about the ammonia engine vehicle, which we started in the year 2013. So we developed a prototype of the vehicle at that time. And these days we started the fuel research again about for the marine engine applications. And I would like to talk a bit about that too today. And this is the picture of the prototype beaker. We named it as AMBI, and just a simple, can I say simple? The name means ammonia beaker, so we abbreviate it as AMBI. And we developed the beaker, and we drove the beaker in the real road to testify the fuel for the conventional engine and beaker. And this slide shows quite an historic image why people started to have the interest on the ammonia fuel. It goes up to almost 20 years ago. In the future, people have thought that in the future we have to utilize the renewable energy to maintain the total energy system, and they think the fuel should be carbon free and low energy consumption, and that means low cost, and they need some on-site production because renewable energy source is located very limited space on the globe. For example, the solar power is located mainly to the equators, and wind is stronger in the southern hemisphere, much more, and the ocean thermal energy is located much more in the place where people does not live. So the fuel must be produced on site, and so we have to utilize electricity to produce the fuel. So ammonia was considered first at that time, so we can learn fuel cell or gas turbine or engine. So this is the starting point of the research. And this shows the ammonia production. These days we have a similar quantity, 200 million tons per year. And people say we consume 3% of total energy to produce ammonia these days. But the decarbonization movement in energy sector, we think 10 times of the consumption of the fuel we expect in from 30 to 50. I mean, 2050, we have to increase the production a lot more than that. Ammonia beaker application is not the phenomena happening these days. Years ago, for example, 1933 and 1943, we have ammonia fueled beakers in Norway and Belgium as well, and we have aviation beaker, which shows Lockheed Martin beakers, and they try to apply ammonia to power the beaker. And recently, in the University of Michigan, they developed a beaker prototype as well. So they used ammonia and gasoline together. They started the engine with gasoline, and then they consumed 80% in full power. So they drove the car from the Detroit to San Francisco in 2007. In 2013, we developed another prototype, as I show you in the only part of my talk. We applied 70% ammonia and 30% of gasoline, and we applied separate fuel injections with the programmable dual fuel ECU. And this is some example of the fuel properties. And ammonia is at the bottom line. And we see that ammonia has a low calorific value and low air-fuel ratio. And this column shows energy contents in the sense of stoichiometric fuel-air mixture. With this figure, we see that 2.64 for ammonia, and we see the gasoline case, we have a 2.58. That means in the mixed state, we can apply ammonia and we can expect much more power than gasoline. Not much more power, but slightly more power. So we can apply ammonia in the conventional gasoline vehicle and diesel vehicle as well. So we try to make another ammonia prototype vehicle in a more advanced fashion. And this is about the engine experimental setup for the SI engine application. At that time, the Hyundai KIER Motor Company, they developed a bi-fuel engine, and they developed a bi-fuel vehicle, which is run by LPG and gasoline selectively. So we installed the engine in the dynamometer shown in this figure, and we applied ammonia and gasoline with separate fuel injection in the intake manifolds with the ammonia gasoline dual fuel ECU. So we can put as much as we want for both for ammonia and gasoline. So we can co-firing after the injection. So this is the ammonia gasoline combustion results, one of the results. Left-hand side shows the pressure development of ammonia substitution of some part of gasoline. And so when we add some ammonia, we have a loss of peak pressure and slow combustion. That is because ammonia burns 5 times slower than gasoline. So we have to advance the spark timing to have a similar pressure trace in the gasoline case. Right-hand side shows you about the heat release rates in those cases. We run the engine, for example, at 1400 RPM with full load. We increase the ammonia ratio of the total fuel. So according to with the fuel increase, ammonia fuel increase, we have the same torque output up to some mixing ratio. Let me say it's about 70%, and then decrease abruptly in this engine. And the spark timing is short, as I told you, we have advanced a lot with ammonia mixing ratios. And this is the CO2 reduction with the ammonia fuel mixing. And that's what we meant to start the research work with the ammonia issues, and we have different road cases. So we have a similar question of the decrease of the greenhouse gas from the engines. About the hydrocarbon and carbon monoxide, we have a similar reduction with the ammonia addition to the engine. So the baseline compared to the baseline, we have a lower hydrocarbon and lower fuel emissions as well. About NOx, there is some many controversy. How much more we may have after the combustion, but up to the certain point, let me say it's about 70% of ammonia mixing, we have a even lower NOx than the gasoline fuels, but increase a lot after some limits. And ammonia, unburned ammonia emission, we have not that much emissions up to some point, but we have again sharp increase after the certain limits. So according to the emission data, we can conclude that we can apply ammonia up to some certain point. When we try to apply ammonia with some conventional fuels in the conventional engines, we can run the engine successfully without any deterioration in emission problems. This is another case with different road conditions. We have a similar pattern of NOx emission. So at some point, we have a comparable lower emission, but in some point, we have a slightly high NOx emissions. And up to the 70% of ammonia fractions, we have a quite low ammonia unburned emission as well. So this is the prototype of the beaker, and the right-hand side shows the engine room of the beaker. We have a different array of injectors for both the ammonia and the gasoline, and we have a catalyst in the bottom of the beaker, and we have the fuel pump as well. After that success, we tried to apply the ammonia in diesel engine as well. So we applied the similar experimental setup, and we have another diesel engine to test the ammonia as shown here. So at that time, we applied the ammonia in the intake manifold as what we did in SI gasoline engine, and we applied diesel engine. And at that time, we tried to reduce diesel fuel quantity, but we were not so successful at the time. We have to add more diesel to make combustion in some cases. This is a diesel combustion baseline. As you can see in the right-hand side, as the load increase, the diesel pressure trace shows the different pressure trace, and we have different emissions according to the fuel quantity, and CO2 increase with the load conditions, but we have a moderate NOx emissions. But and we have a CO2 increase with up to 12% at full load conditions. And this slide shows how we did in the diesel engine. We applied diesel pure, small amount we wanted, but we applied much more than that, and we applied ammonia in different cases. We have a different injection timings. We sweeping the injection timing, and we found that's the torque in the cases. And this is the pure sorry, the cylinder pressure choices at the left-hand side, and we have the energy release on the right-hand side. So when you apply diesel only, this shows the amount of energy released, and we apply ammonia, somehow we have a bit larger energy release. This as well. This is torque output and emissions with ammonia-diesel dual fuel combustion. The baseline is in diesel case, we applied ammonia and we try to maintain the torque output with the same value. With these conditions, we compare the emissions, and we have a quite large emission of ammonia in this case, with moderate increase of NOx emissions. In this case, we were successful only 50% of the fuel from ammonia. We have but we couldn't try to reduce the amount fuel ratio, so it was not successful at the time. And after I was away from the ammonia for some other research work, and then we are trying to back to ammonia these days as well. Again, so we set up another engine, and we applied different kind of fuel, LPG, and natural gas, and ammonia. So we applied to the a combination of the fuels into the intake manifold, as what we did before, and we applied diesel in the combustion chamber. So we try to overcome the combustion stability and the quality, and we have a better emissions. We are trying to beat these things these days. The left-hand side shows the diesel combustion case, and right-hand side is dual fuel case. We have a different ammonia fuel mixing ratio, up to 50% of the total fuel, and with more ammonia additions, we have a slight increase in the BSFC ammonia, while diesel shows quite low BSFC in this case. And the same problem of high unburned ammonia showed up again in this case, up to 5,000. That means the limit of the measurements, so it's a bit more than this value. So that we have the same problem of combustion of ammonia. And in the light load condition, this shows 75% load conditions. We have same problems of emissions as here, but we have a moderate decrease in NOx emission. NOx was not a problem. Only much more problem is happening of the ammonia combustion quality. And this may be the last slide of my talk. And we tried the triple fuel at the same engine, natural gas, ammonia, and diesel. We have a different emissions in the bottom line, and upper line shows the torque outputs. In this case, we apply ammonia and natural gas together, we have a better combustion of ammonia and natural gas combustion, better combustion and better emissions at this time, with the moderate increase of NOx emissions in this case. So we are still struggling to have a better combustion with ammonia fuel and with other fuel supplying methodology as well. So this has been Youngmin from KIER Korea. Thank you very much for listening.
Thank you so much, Dr. Hu. It was very interesting to see how ammonia molecules can be possible. I think we will let all the questions for the discussion session, so please type in discussion your question. Thanks.
Thank you.